Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I will be going over arithmetic sequences. Let's get started. So, arithmetic sequences sound kind of complicated, but in reality, it's pretty easy. It's just a basic pattern. So, to start, what is a pattern? Or a series? Basically, it is a set of terms which increase by a common amount. Let's say if I said rate, that would mean multiplication. So let's just say which increase by a common amount. So, what's a term? I underlined these two words, which I want to go into a little more depth. So, a term is just something that's in a set or a series. So let's say I had the set 1, 2, 3, 4, 5. Each of these numbers is a term. It's just a part of the set. It's just a number. And this common amount can also be known as K. K is what these numbers increase or decrease by. So here, as you can see, you are adding 1 each time. It's very easy, right? There is the common amount that they're increasing is by 1, because 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. Easy enough. So it's not always going to be as easy as this example, but this is basically what all arithmetic series or sequences are like. So, an arithmetic sequence a very simple and basic version that I'm going to give to you is you add the same amount each time. Meaning, it's adding. When you go from one term to the next, it's always adding something. It always goes up by the same amount. There's no change. It's the good old one number that you just keep adding and adding and adding and adding and adding to get the next term. It's as easy as that. So let's say we have 5 terms in a sequence. Okay. And our first term is 10. And our value of K, our constant in this arithmetic sequence, was 5. That means each time when we add, what number are we adding? 5. We are adding 5 each time. So, 10 plus 5, 15. 15 plus 5, 20. 20 plus 5, 25. 25 plus 5, 30. Super easy. That's basically it. So when you look at a word problem, for example, and it wants you to find some term in the sequence. For example, in this example, actually, we found the 5th term. Of course, you could sit there and write out all the numbers and add by that same amount each and every time. Sure, I guess you could do that. But it's going to take a lot of time. It's doable, but not really practical, especially in a test scenario. Or even when you're doing your homework, who wants to sit there adding numbers for like hours and hours? What if you had to find the millionth term? You're going to sit there adding a million numbers? Yeah, I don't think so. So a really easy way to do this is with a little formula. And this formula is the arithmetic for arithmetic sequences, of course. And we're finding the nth term, meaning n is a number. N could be any value. We're just finding the number of a term, meaning the term, like let's say we wanted to find the 100th term. You might see it in a problem like this, n equals 100, meaning we're trying to find the 100th term. Okay? So in this formula that I'm going to show you, pretend n is 100 or any other number. That's what it is. So in this formula, a of n, a subscript n, can also be written as a of n. I will write it both ways. Is a1, our first term, plus d times n minus 1. And I'm mixing up the notation. Wait, but where did d come from? What's d? Remember how I said before we have k? D is the same exact thing. When you find it on your reference sheet with your formulas that you're probably going to get on a standardized test, let's say the SAT or your Regents or a state test, usually it's very likely that this formula is on the reference sheet. I know for a fact it's on the New York State Regents reference sheet. D is the common difference. It's the k in our case, which I had explained earlier. So think of D as difference, the amount that goes up or down. You go up or down by each time. So allow me to explain this formula a little more. What this means is that in order to find, let's say, the 100th term, you take the first term and then you add your common difference, the amount you go up by each time, multiplied by the amount of, like, the term you're trying to find, the 100th, the number of that term, minus 1. But why are we multiplying the difference by 100 minus 1? How does that make any sense? So going back to an example that we did before with the 10, 15, 20 until 30, right? Okay. If we were to write this out again, plus 5, plus 5, plus 5, plus 5. We're finding the 5th term, but we're only adding 5 4 times, not 5. And that is exactly what this problem with this formula is showing right here with n minus 1. You're always adding one less, meaning, yeah, like I said before, 5 terms, but you add it 4 times. If you were trying to find the 100th term, you add 5 only 99 times. If you were looking for the, 1000th term, you're adding 5 999 times. Okay? And that's why we're multiplying our complement difference by that, because adding the same thing 4 times is equal to 5 times 4. Okay, so that is what that means, and let's prove it. I'll try this formula on this example that I have right here just to prove it. If we wanted to find the 5th term, which we already know, we would take the first term, A1, which is 10, plus our complement difference, 5, times 5, the number we're trying to find, minus 1, which equals 10 plus 5 times 4, which equals 10 plus 20, and that is equal to 30. Bam, bam. Checks out. This formula works. So in this video, we went over what arithmetic sequences are and how you can find the nth term or any term in an arithmetic sequence. I hope this video was helpful, and I thank you for watching. Bye!